In this video, I'm going to talk about pressure. Okay, and the formula is given to you on the right. Force divided by area is pressure. There's an alternative way of writing this is by drawing a triangle. Force, pressure, area. So if you wanted to work out, for example, the area, you'd have to do force, this force here, divided by pressure to get the area. Or you could do force, this force over here, divided by the area to give you pressure. Right, the first question is perhaps the easiest. Before I look at this question, just quickly explain to you what pressure is. Right, imagine you're trying to rescue somebody who's trapped, is fallen through ice in a lake or a pond, and you want to rescue that person. Obviously call the fire brigade, but what they could do is they would crawl along the ice rather than walk along the ice. Now think about why they would want to crawl along the ice rather than walk. Now if they're walking on the ice, they're putting a lot more pressure on the soles of their shoes. Right? Remember, the shoe area, the area under the shoes, is not much, and they're putting all that body weight on just those shoes. So they're going to most likely go through the ice. But if they distribute their weight, if they're crawling along the ice and they distribute their weight throughout the body, all over the ice, then they're less likely to go through the ice. They're actually putting less pressure. By doing that, they're putting a lot less pressure on the ice. So to answer this question now, we've got 120 newtons, that's the force, right? That is the force. And we've got the area, all that 120 newtons is distributed around 2 meters squared area. So that's your force and that's your area. Force divided by area. So we've got force over here is 120 newtons, and we've got an area of 2 meters squared. So obviously you're going to do 120 divided by 2, that'll give you 60. But what are the units for the pressure? Can't just leave it at 60. It's going to be newtons per meter squared. Newtons per meter squared. Or you could write it like this, Newton per meter squared. That means each meter squared gets 60 newtons. So if there's 2 meters squared, that's 120 newtons, 3 meters squared, 180 newtons, and so on and so. That's the pressure. Right, next question. A box is placed on the floor. The area of the box in contact with the floor is 2 meters squared. That's your area. Pressure is 16. So now we need to put those numbers in our formula. Area is given as 2.4. Pressure over here is 16 newtons per meter squared. So obviously we need to times these two numbers together. 16 times 2.4. I'm going to use a calculator for this. I get 38.4. Right, I've just worked out the force. Right, here we got newtons, so that'll be newtons. 38.4 newtons. Alright, the next question is a little bit harder. If you look at it carefully, right, I'll just read the question for you. We want to work out the pressure by force that's acting on an area of 30 centimeters squared. Okay, sounds simple, but they want the answer in newtons per meter squared. Now that's a bit of a problem because area is given as centimeter squared, but they want some calculations done so you can give your answer in newton meter squared. So we need to know the connection between meters and centimeters. We know 1 meter is 100 centimeters. That you should know already. 1 meter is 100 centimeters. So 1 meter squared, see, 1 meter squared, that's area, is 100 squared. Right, we need to know what 100 squared is. 100 squared is going to be 10,000. Okay, let me just write that down. Put an extra 2 zeros. 10,000 centimeters squared. 1 meter squared, it's like a small rug, like a carpet, a small rug. It's 10,000 centimeters squared. But I want to convert 30 centimeters squared, this area here, 30 centimeters squared, into meters squared. So how do I do that? I know this number is going to be tiny. It's going to be really tiny. Look, if you look on this side, this is just a 1, and this is 10,000. Right, so the right hand side is a lot bigger, isn't it, than the left hand side. The right hand side number is a lot bigger than the left hand side number. So this number that we're going to get here is going to be a lot smaller than the 30, because the left hand side needs to be smaller. So whatever calculation I do, I need to make sure it's smaller. So if I end up doing something silly like this, 10,000, this is wrong by the way, times 30, I'll get 300,000. Now, doesn't that feel wrong? Didn't I just say the left hand side has to be smaller? Because if you look here, this is just a 1, and here you got 10,000. The left hand side is smaller. So the left hand side needs to be smaller. So instead of timesing, okay, I've realized my mistake. So instead of timesing, what I should have done is I should have divided. So 30 divided by 10,000. Right, my calculator is showing it as standard form, but anyway, that's 0.003 meters squared. Area is 0.003 meters squared. Those are the numbers that I need to put into my formula. So I have it here then. The force is 240. Area is 0.003 meters squared. So now to work at pressure, this one here, I've got to do force divided by area. 240 divided by 0.03. So if I do that, I get 80,000 what? I'm just trying to work out pressure. That's newtons per meter squared. Look, newtons per meter squared is what I've got over here. So you need to be careful. You look at the question, look at the units. Here I had centimeters squared, but they wanted something in the form of meter squared. So that's why I've had to do this conversion work.